In this lecture, you'll learn about layer 2 of the OSI reference model, which is the data link layer. At layer 2, frames are encoded and decoded into bits ready to put onto the physical layer, onto the physical wire. Error detection and correction for the physical layer can be provided here depending on the protocol that we're using. And Ethernet is the layer 2 medium that is used on local area networks. Ethernet is pretty much ubiquitous on the LAN, and that's the layer 2 media that we're going to focus on in this lecture. In later lectures, when we get to the wide area network section, we'll talk about the layer 2 protocols that are used there. But before we start getting into Ethernet, let's actually have a look at some of the different layer 2 protocols. So you can see on my slide here, I've got a link going to a page on Wikipedia where there's a list of network protocols. Let's open that up now. So here I am, and up at the top, it lists some of the common layer 1 protocols like ISDN, DSL. There's a lot of legacy protocols are still listed here as well, like ISDN isn't used so much these days. Then you can see the list of the layer 2 protocols as well. So Ethernet is in here, most commonly used on the LAN. There's a legacy WAN protocol in here, the frame relay. Other kind of protocols we've got in here are FIDI and the point-to-point protocol that we'll be talking about later when we get to the WAN section. Okay, so that's where you can see the different protocols that operate at the different layers. Let's go back to the slides. And the next thing I wanted to do was just clear up any misunderstanding you may have about the terminology, because this has been mentioned a few times as we've been going through the OSI lectures, but I just want to really make it clear here. So you've seen this slide several times before. We're going to look at the terminology now. When a packet is composed, obviously it's composed by the sender and it's going to put it on the wire and send it to the receiver. And as we go down through the OSI model, the sender will start off at the top layer, the application layer, and it will compose that part of the PDU. Then after it's done that, layer 7 will get encapsulated in the layer 6 header. At layer 7, at that point, it's called the data. We then encapsulate it in the layer 5 header and then in the layer 4 header. When we put the layer 4 header on there, at that point it's called a segment. Then the layer 3 header goes on. At that point it's called a packet. And then finally the layer 2, the data link layer, will go on, and at that point it's called a frame. But when the sender is sending traffic to the receiver, it's not like it sends segments, packets, and frames separately. They're all part of the same PDU. It's really just terminology that we're talking about here. So we send that one PDU. When we're looking at it from the point of view of layer 4, we call it the segment. From the point of view of layer 3, it's a packet. And from the point of view of layer 2, it's a frame. Moving on, let's look at that layer 2 Ethernet header, if it is Ethernet that we're using as our layer 2 protocol. So at the start of the header, we've got the preamble. That's used to help the sender and the receiver to synchronize. We then have the layer 2 destination and source address. That's the MAC address when we're using Ethernet. We then have the ether type, which is used to specify what is encapsulated inside the Ethernet header, so that will typically be IP version 4. We then have the data and the FCS. The FCS is the frame check sequence. That's a cyclical redundancy check, which is used to check for the integrity of the frame, to check that it has not been corrupted during transit. So lastly, let's look at that layer 2 Ethernet address, which is the MAC address. MAC stands for Media Access Control. The MAC address is a 40-bit hexadecimal address. If we look back a slide, 6 bytes, each byte is 8 bits, so 6 times 8, that's where we get the 48 bits from. And the MAC address is split into two different halves as concerns what makes up the MAC address. The first half, so the first 24 bits, is the OUI. That's the organizationally unique identifier, and that identifier is the manufacturer of the Ethernet port. So if you've got a Cisco router or switch and it's got an Ethernet port on there, it will have a MAC address, and the first half of the MAC address is Cisco's identifier. If you had a network card and that network card came from IBM, for example, the first half of the MAC address is going to be IBM's identifier. The second half of the address, so the last 24 bits, that is assigned by the manufacturer. And the burned-in MAC address on every NIC port in the world is globally unique. The actual number of potential addresses is 2 to the power of 48, or if you have a look at the slide, this absolutely huge big number, 281 quadrillion or whatever it is. There's a lot of possible MAC addresses, so that makes it possible for every Ethernet port in the world to have a unique MAC address. An important point that I want to make here is that there's no logical addressing with your MAC addresses. It's just one big flat address space. We could have a PC with a network card from IBM, so it's going to have an IBM MAC address on there. That could be in New York. We could have another one also from IBM in Beijing and another PC from IBM in London. So they're not grouped together. There's no kind of logical order with your MAC addresses, just one big flat address space. And that's why this section is a lot shorter than the section where we were talking about IP addresses. With IP addresses, there is a logical order there, and that's how we as administrators are going to control our networking. Last thing to do in this lecture is I want to show you how to get information about the MAC address. I'm on my laptop here, which is on Windows, so let's see how to get the MAC address on a Windows machine. So I'm going to open up a command prompt here. I type in cmd, and then the command is ipconfig, a space, and then /all to get the MAC address. I've got a whole heap of output here because I'm running VMware on my laptop, so I've got a lot of virtual adapters. If I scroll back and then find my wireless adapter, which is going to be in this list somewhere, let me just keep scrolling through until I find it. Okay, here it is. So my wireless network adapter, because I'm on wireless now, both wireless and wired Ethernet, both uses a MAC address. And the entry here, physical address, that is the MAC address. So my MAC address on my laptop is 685D43245801. Okay, so that's how to find it on Windows. Let's have a look at Linux next. So I'm going to open up PuTTY, and I'm going to SSH into a Linux box that I've got running. So I'm going to secure shell in here, enter my username and my password, and I'll get the command prompt in Linux. So on Windows, it was ipconfig, and you have to use /all to get the MAC address. In Linux, it's ifconfig for interface configuration. And I'll scroll up a little bit here. You can see here's my Ethernet interface that I'm using here. The MAC address is the hardware address. So that's 000C29 is the OUI portion, and then the vendor assigned portion, C4E87E. Okay, so that's how we find the MAC address on Windows and Linux. Finally, let's have a look on a Cisco router or switch. So I'm going to open up another PuTTY session, and this time I'm going to SSH onto my router. I need to enter enable to get to the enable prompt, and then the command is show interface. This is going to give me a heap of output about all my different interfaces. I could also have just entered one interface if I wanted to there to more target the output. And I can see on Fast Ethernet 0/0, the address is 00187374 8D56. In brackets here, it tells me the BIA, that's the burned in address, and it's exactly the same value here. The reason there's a difference, it is possible in software to change the MAC address on an interface, but normally we won't do that. Normally we'll just leave it at the burned in address from the manufacturer. Okay, so that was everything I needed to tell you about MAC addresses. See you in the next lecture.